Here we're going to see how from a graph of a parabola we can write an equation for the parabola in three different ways: in intercept form, vertex form, and standard form. And of course this only works if a parabola does in fact have any intercepts along the x-axis. If it's a parabola that doesn't, we wouldn't be able to use that form. So you'll see that I have two examples here where it does in fact cross the x-axis twice, so there will be two intercepts. So when you have to come up with those three forms, you can start with either intercept or vertex and leave standard form until the very end, and I'll show you how to do that. So when I look at this parabola, I might ask myself, what's it easier to start with? Is it easier to start with vertex form or intercept form? And on your version of the graph, you can actually read the intercept values, but you are also given the vertex. So for the sake of some variety, I'm going to start this one with a vertex form, then do intercept form, and then do standard form. So when I do vertex form, I know that the general formula for vertex form is y equals a times x minus h squared plus k. Okay. Now I am given the vertex right here, -4, -9. So I can plug in -4 for h and I can plug in -9 for k. I also will need to find an a value. Okay, and the only way I'm going to get that a value is trying to read it off the graph directly, but I can use algebra to solve it for sure, especially if it's not an integer value. So I will need another point off of the graph in order to be able to do that, and it can be any of these points at all. So I'm going to choose to use the point right here that you can read off your graph, your version, because it is truly an intercept. It's -1, 0. So I'm going to take a moment to plug in this point here for x and y. So x is -1, y is 0, minus h is -4 squared, and then plus k is -9. So let's clean this up and see if we can solve for the a value, which will be true no matter which form of the equation we derive for this parabola. So inside the brackets I have -4 minus -4. So that's the same as -1 minus -4. So -1 plus 4 means inside this brackets I have plus 3. And when I'm doing BEDMAS, brackets comes first ahead of exponents. And then plus minus 9 just can be written as minus 9 as such. So I have this, I'm trying to solve for a. I'm going to take this -9 to the other side by adding 9 to both sides. And I can do 3 squared. 3 squared is 9. A common mistake students do make before I go any further is they'll do 9 minus 9 and put a times 0. We can't do that. Subtraction does not occur ahead of multiplication, brackets, and exponents. We have to do brackets and exponents first. So this becomes a times 9. Well, you might be familiar with it if you see it this way. 9 equals 9a. If I divide both sides by 9, I'm going to get a is equal to 1. So therefore, the vertex form of this parabola is y equals, let's put in our a value of 1, or you can choose not to write it, you'll know it's there. X minus -4 means it'll be plus 4 squared, and then plus -9 means we'll have -9 out here. All right, from there we can do intercept form. The other intercept that's over here, and I'm just going to change colors with it because I want it to be my intercept color that I've chosen in previous videos. This is -1, 0, and off of your graph, this one is -7, 0. So we know the general formula for intercept form is y equals a, x minus r, x minus s. So we can come up with the intercept version, or factored version if you like, quite easily by subbing in a, we've already got it, and r and s. So let's do that. Y equals 1. You can put the 1 there or leave it. X minus r. So x minus -7 means I'm going to write x plus 7. And x minus -1 means I'm going to write x plus 1. And so therefore, that equation is the intercept form. For this parabola. So, how do we go to standard form? Well, standard form can be deduced one of two ways. I can either expand vertex form, and that will give me standard form, or I can expand intercept form, and that will give me standard form. And it shouldn't matter which one I do, it should come out exactly the same. Okay? I'm going to do it in this example for both of them to prove that to you. Okay? So if I'm going for standard form this way, I'm going to write y equals x plus 4 times x plus 4 minus 9. If I FOIL that, I'm going to have x squared. I'm going to have 4x on the outside, 4x on the inside, if it's okay with you. I'm going to put those together to make 8x. And then 4 times 4 is 16. I can combine these two terms to give me the final equation. 16 minus 9 would be plus 7. And if you don't believe me, we could expand this one too. Let's do it. So y equals, let's do FOIL. First is x squared. Outsides are x, along with inside is 7x. I can put those together to make 8x, and then multiplying the last gives me 7. So look, they're exactly the same. Now, which way is easier? I think foiling out the intercept form might be a little bit easier than having to write a couple of extra lines with this one, but it's a good check to make sure that it works. If it doesn't, then you've got an error somewhere. Maybe you made a negative error in here, or maybe your value of a was a little mucky, okay? But all three forms, when you put them into decimals, for example, should yield you the exact same parabola. I'm going to erase this one just for space. And let's go on to the next example. So in the next example, we're also asked to come up with 3 different versions of an equation for this parabola. Okay, vertex, intercept, or factored form, and standard form. So where would you start? Well, from this one, you aren't explicitly given any labels, okay, but you are able to read them off your graph because you have grid lines. Let's read off what those important points are, and you are given another point here too. We do know that the vertex is at 118, and we do know that the x-intercepts, or the roots, are at 4, 0 to the right of the y-axis and negative 2, 0 to the left of the x-axis. So I'm going to do this one a slightly different way. We could go through the exact same process using the vertex, but what if you couldn't read the vertex? What if all you had were the intercepts? So let's start with intercept form this time instead. I know that the general form is y equals a times x minus r times x minus s. I don't know a from reading it off the graph. I mean, I might be able to read it directly, but I'd like to show you how to solve it algebraically too. So that means that I'm going to have to sub in something for r and s. That would be these two roots or x-intercepts here. And I'm going to need to find one other point to put in for x and y. Now I could choose the vertex, but I think I'm going to choose this one because working with a 0 is going to make life a little bit simpler mathematically. So let's do that substitution at this point to solve for a. So my y value will be 16 from my other point. I don't know a. I have 0 for x minus negative 2 for r, and 0, because this is the same x, minus 4 for s. Let's simplify this. 16 is equal to a times, this will become 0 minus negative 2, which is plus 2, and 0 minus 4 will be negative 4. Now, I'm not used to seeing the literal part of a term at the beginning and the numerical parts at the end, but I can switch the order because I'm multiplying them together. So I can make this into 16 equals negative 8a. And if I want to solve for a, I can divide both sides by negative 8, and I find that a is negative 2. And that's reasonable. Okay, it's downward, so I would expect a to be negative, and it seems a little narrower widthwise when you look at the fact that these all go up by ones and by ones compared to our friend y equals x squared that we've seen so many times. Now once you have that a value, it's the same a value for all the forms. So now we can do vertex form. So vertex form is y equals a times x minus h squared plus k. By the way, these general formulas for intercept form, vertex form, and standard form, ax squared plus bx plus c, would always be given to you on a summative assessment. But I think you'll find that you're going to get to learn them through practice anyway. So at this point, if we want to come up with the equation, we can sub in a value because we know it's -2. And we can sub in for h because we know its value. So we can go x minus +1 plus, subbing in for k, we have plus 18. Let's simplify the signs. So it's -2 times x minus 1 quantity squared plus 18. And there is your equation in vertex form. And we'll just finish off back here. This one, we didn't finish the equation. We got to a and I jumped. We should go back and finish it, my bad. So therefore, y equals, our a value is -2. We have x minus -2, which means it's going to be x plus 2. And we have x minus 4, which means it will be x minus 4 here, is the equation in intercept form or factored form. Okay, so we have two of the versions. We just need to do standard. We learned up above that finding standard form can be done through either expanding vertex form or expanding intercept form. And we noticed that maybe this one is a little bit easier. So let's try it. Now back from our chapter 5 lessons, you may remember that I said to you when you have a monomial times a binomial, do FOIL first. And then we'll distribute the -2 at the end. It just prevents a lot of careless mistakes. So when I FOIL this, I will have x squared. On the outside, I will have -4x, and on the inside, I will have +2x. That means that I have 2 more negative x's than I do positive x's. And then if I do the last, I will have -8. Finally, I can distribute the -2 to each of those terms. So I'm going to have -2x squared. I have to watch my signs here. -2 times -2 is positive 4x, and -2 times -8 is positive 16. And this would be the equation for this parabola in standard form. I just noticed I had a typo up above. This isn't standard form, this is vertex form. Jumping ahead of myself here. Can you allow me to fix that? And there you have it. Ways that you can, from a graph, or you could be given these as a description too, right? You might have it in words, but then sketching it out will help you to see all the pieces. You can come up with the 3 different versions, okay, when the parabola in fact does have intercepts. If it doesn't, we can't. Okay, I'm going to pause this video here and start a new one just for our final example in this lesson.